Advanced Wide Area Network Configuration Part 2 Frame Relay. And I can't think of a technology that I feared more when I first got into Cisco routers than frame relay. I have to confess, it took years for me to get over my fears with frame relay and really start configuring it because it was just that mystery technology. And I've met many technicians out there in the field just like I used to be, where it's kind of like, oh, frame relay, we'll hire the consultant. We'll use the managed router that we don't have to deal with the frame relay aspect of it because it's just very odd. Well, in this nugget, I plan on number one going through all of those mystical terms, the strange connection types that we'll have with frame relay, because it's one of the only types of networks out there that you'll have mismatches between your physical speed and your logical connection speeds, and we'll talk all about that. We'll finally spend the vast majority of this chapter on the frame relay configuration, and we're going to get into some very advanced configuration examples when we get there and throw a hybrid topology at you with a multi-point, a point-to-point interface, combine it all together to get you ready for some of the style of stuff that you'll see when you get to that CCIE lab. But wait, before we even get into the terminology, I want to answer the big why question. Why was frame relay created in the first place? Well, back in the day, all the service providers gave people was lease lines. T1s, fractional T1s, ISDN, that sort of thing. And essentially, the service providers monitored the connection, and they were saying, you know what, this is a big waste because people are really only using, their bandwidth maybe 20 or 30% of the time. The rest of it is going to waste, and we can't get it back. We can't use it because we've guaranteed that that bandwidth would be there for them. So what they did was they created a cloud, and it started with X.25 but evolved towards frame relay, which is just a big cloud of shared bandwidth. And think of it this way. You've probably been to a 50s joint somewhere in your life where you have the 50s restaurants, and you might have ordered a milkshake of some sort, right? And at those places, they always bring you a huge milkshake and this little leftovers cup, this little tin can with leftover milkshake substance. And I suppose if you had an entrepreneurial spirit, you could go ahead and start selling that milkshake to all the people in the restaurant, and you could start charging them based on the size of the straw because you can't drink it all. So you might say, well, for a McDonald's straw, you can share my milkshake for $1. If you want a coffee stir, maybe it's 10 cents. And frame relay worked the same way. The service provider would just put together this big pool of bandwidth that everybody shared, and the straw size, or how much committed information rate, which is what one of the terms we're going to get to, you demanded, is really going to affect what you paid for. And here's the key of frame relay. If you're not using the bandwidth, somebody else is. That's the big benefit to the service provider, and that benefit is passed on to you with the cost. So here's the terms. First off is permanent virtual circuit. Since frame relay is a big shared pool of bandwidth, you have to have these virtual circuits which essentially emulate as if you were physically connected. We have 3 routers down here. None of them are physically connected together. They are in no way connected. They go through this huge switching network in the service router. They might go through 50 different switches before reaching the other side, but the PVC structure makes the routers think that they're directly connected. That's what a permanent virtual circuit is. A DELC is the path that you use to get there. And this is why frame relay is so confusing, is because a DELC is unlike anything that most people have seen. Most people think of, when they're trying to get to a device, going to some sort of destination address, right? You want to go to a destination MAC address or a destination IP address. Well, here, instead of going to a destination DELC, we're leaving on a source DELC. And here's how I think of it. You've taken a plane ride. You might have taken a plane ride somewhere in your life. When you fly to a destination, say I'm flying from Arizona to Missouri, I'm going to jump on a plane and I have a departing flight number. Now that flight number will get me to Missouri, but when I come back from Missouri, the flight number may be totally different. In the same sense, check this out. We've got a router that uses DELC 105. That's its departing flight number to reach, maybe this is the Missouri router over here. And it will arrive and land as DELC 501. They don't have to be the same. These DELCs are locally significant. So instead of sending to a destination DELC, you're kind of sending to a departing flight Delcy, departing flight of 105, which will help you reach the other sides. These numbers are only locally significant because they help the service provider decide and figure out what path through the frame relay network you're going to use to get to that other side. Speaking of the service provider, we have the local management interface, or LMI. And all this is the language of love between your router and the service provider, because the service provider is going to be giving you this list of DELCs, this list of flight numbers, and you're going to need to communicate with that language, local management interface, to the service provider. Thankfully, our routers nowadays using a modern iOS will be able to auto-detect that language and communicate without a problem. Now, the network-to-network interface is not a well-known one, NNI. This is the language that the service provider uses all the way through their network. I mean, it looks really simple when you just draw a diagram like this with a few DELCs and paths going through, but to a service provider, they have to do a lot of configuration in here to have all these switches communicate together. Well, they all speak together using NNI, network-to-network interface. Finally, the big one that affects how much you pay for. Local access rate and committed information rate. The local access rate is the physical connection speed. When you sign up for a frame relay connection, someone's going to physically drive out to your location, physically plug in a box, and they will say that interface on that box can only handle 1.544 megabits per second. Maybe it's a maximum physical rate of T1. But then you also have to negotiate your committed information rate. That is what the service provider commits that you'll get. And this is the great thing about frame relay, is that the CIR is just the lowest level. You might negotiate a CIR of 128 kilobits per second. But the beauty is if someone in the frame relay cloud isn't using all of their bandwidth, you may be able to get a little bonus bandwidth. Yes, they'll commit that you get 128K, but you might be able to get 200 kilobits per second or 300 kilobits per second, depending on how much bandwidth is free in that cloud when you send your data. Again, committed information rate, going back to the original analogy, is like that straw size. The more you pay, the bigger your straw that the service provider guarantees you'll have when connecting to that frame relay cloud. Without further ado, let's get into why we're all here, the configuration of frame relay and setting it up in a variety of scenarios. We're going to start off with a base configuration, just letting frame relay be frame relay and take care of itself with inverse ARP. But in many scenarios, both lab-based and real-world, that's not good enough. There's going to be strange situations and strange configurations where we're going to have to add a manual configuration. We're going to turn off the automatic configuration and configure sub-interfaces. And as we do that, I'm going to create a hybrid configuration example showing both sub-interfaces in use at exactly the same time and connecting to routers that aren't using sub-interfaces at all. It's hard to describe without seeing the topology, so once we get there, you'll understand. All throughout this, I have a specific verification section, but all throughout this, I'm going to be using a variety of commands that are really handy to troubleshoot frame relay and that I've found useful when I've been working with frame relay all the time. And then I'll just wrap it up with some other commands of note, stuff that you don't use every day, but it's still useful to know. Because they can be useful in not only troubleshooting, but allowing frame relay to do some tricky things. Starting off with the foundation configuration, here's what we're going to do. We have just a router sitting here in Goodyear, Arizona, connecting to a router sitting in Dixieland, California. And we have a point-to-point frame relay connection, and this is probably one of the only scenarios where I could see us using just the base configuration, which really allows frame relay to configure itself. Now, you can have a little more advanced topology than this. However, once you get to those more advanced topologies, which we'll look at in a moment, you really want control over exactly how your routing is going to take place across that cloud. So let me pop up the terminal. It's sitting here in Goodyear. Let's get into global configuration mode. And I'll go into interface serial 0/0. And what I'm going to do is I'm going to enable frame relay encapsulation. So I'll just type in encapsulation frame relay. We're chugging away on there. And for this base configuration, I've already set up the IP address. We can just do a no shutdown. And what we'll see is this interface will begin configuring itself. It's going to communicate with the service provider using LMI, that local management interface, the language of love between you and the service provider, and get the list of DLCs that it can communicate with. But before we jump over to Dixieland and do the same configuration, let's do a show frame relay LMI. And what we'll see here is a lot of information of the communication with the service provider. I, in my entire life, have never used any of this stuff. The only line that I've used is this one right here. Very valuable line. It says the number of status messages that you've sent to the service provider using LMI, and the number of status messages that you've received from the service provider using LMI. Now, what it should be is within one or two of each other. If you see these really veering off from each other and not matching up at all, that means you probably have either an LMI mismatch or you're just not communicating with your service provider. You'll typically see many of them sent and none of them received, which means you're not communicating with the service provider. We also see the LMI type up here, which was auto-detected by our router to be Cisco. I know it says Cisco, but that LMI type is actually used by three major vendors. They sometimes call it the Gang of Three. I've heard it called the Gang of Four at times as well, because some other vendors began adopting it. Cisco Digital, which is known as DEC, and Northern Telecom all use the LMI type of Cisco. You might also see the other two LMI types, which is ANSI and Q933A. Let me drill into this a little more and do a show interface serial 0/0, because each one of these LMI types will actually pick a DLC to send and receive data on. Now, with the Cisco LMI type, what you see here is we have LMI DLC 1023. Now, I know we talked about the DLC being the data link connection identifier that we use to communicate to the other side of our frame relay clouds, but with the LMI signal line, I don't want this to throw you off at all. LMI will pick a DLC to use in sending all of the information to use. With Cisco and the LMI type known as ANSI, ANSI, it uses DLC 1023. There's one other LMI signaling type called Q933A that will pick a DLC of 0. Now, this is not used for communication with the other side. It's just used as kind of a data channel for the service provider to send you all the information. Let's jump over to Dixieland and configure that side. Here I am in Dixieland, do a show interface, and I've already configured the IP address on the serial 0, so all we should need to do is get in there and type in encapsulation frame relay, followed by no shut to bring that interface up. And the beauty of this base configuration is inverse ARP should take care of the rest. Here's what's going to happen. The service provider will send the DLCs to Goodyear and to Dixieland. So they will know that I can get somewhere using DLC 201, that's Dixieland's departing flight number, to reach Goodyear, and Goodyear's knows that it can get somewhere using DLC 102. So what it will do is it will send inverse ARP messages, which is just like yelling. It's saying, hello, I have a DLC. Is someone out there on this DLC? So that message goes from Goodyear to Arizona or to Dixieland. Dixieland receives that and says, "Oh yeah, I'm out here. I'm on. You reached me using DLC 102. Here's the IP address on the other side." And you see a status message that came across here, DLC 201. The state changed to active. There are 3 major states. As a matter of fact, let me do this. And I'll show you one of the big disadvantages of inverse ARP in the CCIE lab environment in this time too. I'll do a show frame relay map. In this case, I see my one DLC that I've learned, DLC 201. It was learned dynamically, which means it didn't have to be statically configured. The broadcast keyword is allowed, meaning it's allowed to send broadcast across there, which I'll talk about in a moment. That's used for routing protocols. And the status defined is active. One of 3 statuses can be in place. As a matter of fact, I'm going to jump back to the whiteboard and show these to you so you can really understand troubleshooting with frame relay. I went ahead and paused the video recording and jotted these things on the whiteboard because these Delcy states can make or break your frame relay connection and really decrease your troubleshooting time. Let's talk about them. First off, we just saw a Delcy state of active, and what that means, and that was from the perspective of Dixieland, the local and remote Delcy connection, layer 2 frame relay communication, is working. So if you see a Delcy state of active, that means you are connecting and the remote router is also connecting that you are communicating with. Inactive, if you see a state of inactive, means that your connection is working, but the remote router is not. It means that your Dixieland router is coming here, and the service provider says, yep, there's a Delcy 201, but I can't get you through to the other side. Something is going on over in Goodyear if it's, in that case, set as inactive. Deleted means the local connection is not working. Dixieland is coming to the frame relay provider saying, I want to use Delcy 201, and the frame relay service provider is going, what's Delcy 201? I don't know what that is. So the local connection is not working. The remote connection is unknown. It's pretty much saying if you can't connect, I'm not too sure what you're trying to connect to on the other side, so I'm unable to verify it. Typically, the reason you'll end up with a deleted Delcy is if you statically configure one on your router. You go into Dixieland and say, I want to statically use Delcy 209, and the service provider says, I don't have 209. What is that Delcy? That's when you'll see a status of deleted. So let's get back into the configuration, and I'm going to jump back on Disneyland, Dixieland, and you know, I don't think we've done the most obvious test, and that's to ping the other side. So let's make sure we can reach Goodyear through the PVC, and sure enough we can. Life is good. Cool. So let me just make sure I've covered everything. My favorite command is this show frame relay map, because it's very concise output as to what Delcys have been mapped to IP addresses. But as we get into the next conversation, which is the manual configuration, let me show you a different command. It's the twin brother of show frame relay map. It's show frame relay PVC. And I like the show frame relay map because it's so concise. The show frame relay PVC gives you all the information about the circuit, like how many packets you've sent, how many bytes have been sent. We see the status, in this case, is active right up here. What Delcy number it is. You get a lot of good information. It's just not as concise. But let me spin this back towards the CCIE lab. In the real world, the service provider will only give you exactly what Delcys you need. Dixieland would only get Delcy 201 in this case, because that way it can only connect to Goodyear. It'd be a security hazard if the service provider started giving you Delcys to connect to other customers. But in the CCIE lab, it is not so. Cisco never claimed that the CCIE lab was of best practices, but rather that you know how to do it. So let me hit the space bar, and you look at this. Delcy 203, where's that going? And I'm seeing the status is inactive, which means Dixieland's getting it, but some remote router's not configured yet. We have 204, 205. We have all these Delcys that are coming from nowhere. And the problem is, in the CCIE lab, you're going to have a topology. You're going to have this diagram of networks and router connections, but they're going to configure more virtual circuits than you need. And you're going to have virtual circuits pointing to routers that you shouldn't be connecting to. And if inverse ARP is turned on, here's the key I want you to catch. We see them as the virtual circuit, but if inverse ARP is on, what's going to happen is your router will begin mapping the remote IP addresses. So you're going to have a false topology. Your router is going to be reaching other routers that it shouldn't be reaching according to the CCIE lab topology. So what we're going to need to do is to turn off inverse ARP and spin it toward a manual configuration. In order to do that, I'm going to expand our network topology beyond just the Goodyear Dixieland connection. Now I've got Goodyear connecting to Dixieland, California, Dogtown, California, and Cactus, California. We have all of these different Delcys that are helping us reach there, and you can see the Delcy numbers on the screen. And what I'm going to do is I'm going to take Goodyear and convert it to a sub-interface configuration. And the reason I'm going to do that is it will help demonstrate the two different types of sub-interfaces. The .1 sub-interface I'm going to have being a point-to-point sub-interface. The .2 sub-interface I'm going to have be a point-to-multipoint sub-interface. So that will allow us to connect from the .2 side over to the Dogtown and Cactus on one subnet and Dixieland on a separate one. Now before we even get going with this, the first question I have is, number one, would it be possible to do this with just a single interface? Well, looking at the topology, no, not with this configuration, and there's two reasons why. Number one, Dixieland is on a different subnet. And once we've breached into a different subnet, you see 10.1.1 is the subnet Dixieland's on. We've got 172.16.1, 172.16.1, 172.16.1. We've got a separate subnet, and once we've done that, we need to break off into a different interface to handle that subnet. But the second reason why this wouldn't be good on a straight interface configuration is because of our good old friend Split Horizon. You remember Split Horizon? That's when you're having your routing protocols. Imagine that behind Dixieland you had your subnet, of local computers. Behind Dogtown you had that subnet of local computers in Dogtown. They're going to be sending routing updates advertising that subnet. And with Split Horizon, the rule says never send something in the same direction that it was received on. It would come from Dixieland into Goodyear. Now this is without subinterfaces. So it would come in serial 0/0, and the Split Horizon rule would say never send it back out because that could cause a routing loop. So Dogtown and Cactus would never hear about the local area network configured in Dixieland. They wouldn't be able to reach it. So because of that, we want to break it into a sub-interface configuration. Now, my personal opinion, I can't stand point-to-multipoint subinterfaces. If I had the opportunity, I would configure everything everywhere point-to-point, and in the real world, I do. However, on the CCIE lab, they do throw these on there, and the main reason why, I've got to be straightforward with you, is it's making it more difficult. Point-to-multipoint throws a whole bunch of challenges of its own. So let's go ahead and bring up our router and just clear this all off and get back to the base configuration. Let's bring up this router and start walking through the sub-interface configuration over on Goodyear. So let's jump on over to the Goodyear router. And the first thing I want to do, just get my bearings, is to do a show IP interface brief. And okay, there we go. We got the serial 0 interface. There's our IP address. We have a LAN interface configured, or a loopback to emulate the LAN. So let's get into the interface serial 0/0, and I'm going to show you two commands that you just need to get in the habit of typing in on every frame relay interface when you are thinking about the CCIE. It is no frame relay inverse ARP. That's the first one. No frame relay inverse ARP keeps Goodyear from trying to auto-discover what's beyond these DELCs, what's on the other side of these DELCs, to find out what the IP address to DELC mappings are going to be. The reason I do that, and this, by the way, let me step back from the real world and just say this is specific to the CCIE lab. Normally in the real world, it's okay to have inverse ARP running because the service provider is trustworthy. You won't have bogus frame relay DELCs being thrown at you from all over the place. Another command that you may have seen before is no ARP frame relay. This one is really redundant because what no frame relay inverse ARP does is it keeps Goodyear from trying to discover what's on the other side. What this one does, no ARP frame relay, is it says to Goodyear, if anybody is coming to you and trying to discover who you are, don't tell them, don't respond. So if you configure this command everywhere, you won't really have to worry about the second one, but in the CCIE lab, you can never be too safe. I usually just type in both out of habit. Now, since we're converting to a sub-interface configuration, I want to remove that IP address. I'm just going to type in no IP address. So all that we have on the interface is just encapsulation frame relay, no inverse ARP turned on, so we are not learning about anything. And I'm also going to jump back out to privilege mode and just do a clear frame relay, and I'll type in inarp to clear all of the mappings that I had in the mapping table, because it does keep those. So now I'll get into global configuration and configure the first sub-interface. I'm looking at the diagram. It looks like we've got a point-to-point sitting right up there, so let's do that one first. I'll do interface serial 0/0.1, and I'm going to type in that this is a point-to-point sub-interface. You will not get these options, these sub-interface options we see right here, if you don't have encapsulation frame relay turned on the main interface. Under here is where I'm going to put that IP address. The old IP address that used to be on the main interface. And under the point-to-point sub-interface mode, to assign the DELC, since we're not auto-discovering anything, we use a unique command. It's interface, or frame relay, interface DELC, and then you type in the number of the Delcy you want to assign, 102. It doesn't need to have a map of what's on the other side because it's just going to send everything down that Delcy. It's saying, you know what, I don't even know where I'm going. I'm just sending it down this Delcy because I know that this is a point-to-point interface. There is only one neighbor that I'm ever going to reach on the other side of that Delcy. You notice it put us into this Delcy configuration mode as well, which is an odd one. This is where we can apply some of our traffic shaping parameters, which we're going to talk about in just a little bit. And you notice EIGRP, which I have running in the background, reform that neighbor relationship with Dixieland. So we're up and running there. Good. So we've got one subinterface configured. Let's set up the second one. I'm going to type in interface serial 0/0.2 now, and this one, since this is a hybrid configuration, let me get to my topology here. This one is going to be a point to multi-point configuration. 172.16.1.1 is the address, and it will connect to both Dogtown and Cactus. So I'm going to type in multi-point, hit enter, and I'm now under the sub interface. Give it its IP address. And now we're going to do our frame relay map commands. This is different than the frame relay interface Delcy command we just saw before. Since this is a multi-point subinterface, it's going to be pointing to multiple destinations, so we need to map each one of them. To do that, we're going to use the frame relay map syntax. I'll type in frame-relay map, followed by what protocol we would like to map. Now this is a pretty limited iOS I have on here. It's an IP only subset, so I'll just type in IP, followed by the remote IP address that I'd like to map. I'm mapping, in this case, let's start with Goodyear over to Dogtown. I'm going to map this IP address, that's who I can reach, to the Delcy I used to reach them. So bring it back up, 172.16.1.2 is Dogtown, and the Delcy that I use to get there is 103. That's my departing flight number. Now after this, I have a plethora of options that I can add to this. The first one that I always type in is broadcast, because without that keyword typed in, you won't be able to run routing protocols to those two routers because they will block broadcast. The frame relay interface by default blocks multicast and broadcast traffic, which is what EIGRP is going to use to communicate the routing updates to the other side. So I just always get in the habit of typing that. We see some other options on here like Cisco, if you want to use a Cisco encapsulation. That's an old proprietary Cisco encapsulation that they came out with when communicating with Cisco routers. That's actually on by default. If it's a non-Cisco router on the other end, you want to use IETF frame relay encapsulation to communicate. You can also enable some compression options, but really all that I want to enable here is just broadcast. I'll hit the up arrow and do the other mapping. We're going to now say 104, Delcy 104, let's get back to the diagram here. 104 is going to reach Cactus, which is 172.16.1.3. Make that change. 172.16.1.3. Okay, we're good to go. And we should now have everything under that sub-interface that we need. I'm just thinking it over in my mind. Let me just do a show IP interface brief. There's our two sub-interface. We have 172.16.1.1. I'll do a show frame relay map. And we can see now, good output. We see Delcy 104 status. This is Delcy 104 is the bottom one. This is static mapping rather than the dynamic we just saw a moment ago when we did the point-to-point configuration. We see that the status is inactive because I've got Goodyear configured, but the remote router isn't configured. If it were deleted, that means Goodyear is configured incorrectly. We see both of them under the serial 0.2 are currently down because both of them are inactive. The only one that's up right now is the serial 0/0.1. That's the point-to-point configuration that we have reaching Dixieland. So let's jump on over to those other two routers and configure them. I'll hop on over first off to Dogtown, clear off the screen so we can start afresh on this router. And we'll start with the show IP interface brief so that we can see, again, the interfaces that are running on this router. Beforehand, I already went up and assigned the IP address of the serial 0/0 interface, so it's good to go. But I haven't configured any of the frame relay options, so let's do that. interface serial 0/0, and trust me, you'll get in this habit pretty quickly. And cat frame, no frame, inverse ARP, no ARP frame. That's my, it comes brainlessly to me at this point just to type those 3 commands in there. Now we'll go ahead and assign the IP address. 172.16.1.2, if I remember correctly back on that diagram. Yep. Class C subnet mask, and we're good there. Now we'll need to set up our frame relay map statement. So I'm going to type in frame map IP. We're going to map the Delcy to Goodyear, so it would be 172.16.1.1 is the remote IP address from Dogtown that we're reaching over at Goodyear. The Delcy that we use to get there now is 301. And I'll go ahead and attach that broadcast keyword onto there. Now remember, without this frame relay map, we can't communicate. We've turned off inverse ARP. We can't discover who's on the other side by ourselves, so we're forced to use static mappings, which in the case of the CCIA lab is a good thing because dynamically you will get a bunch of false information fed to you. Oh, what am I doing? No auto. I meant no shutdown. I was thinking auto configuration. So no shutdown should bring this interface up, and we should see that Delcy go active as it's communicating with the service provider. Let's do a show frame relay map. Beauty. We've got Delcy 301 mapped to the correct IP address, and it has now gone active. So we should be able to ping Goodyear at this point. Ping 172.16.1.1. All right, cool. So we can now reach from Dogtown up to Goodyear. Let's jump over to Cactus and do the last one, and I'll just fly through that. That'll be a good flyby review. Global config, interface serial 0, and cap frame, no frame inverse, no ARP frame. Frame map IP 172.16.1.1. And what Delcy are we using? From Cactus, we're getting to Goodyear using Delcy 401. I'll include the broadcast keyword, no shut, and we should be good. Big problem already. We see the Delcy status change to active. Let's do a show frame map. Oh, inactive. Okay, there it goes. Whew, took a sec there. So we see the Delcy has changed to active. Looks like we have a few of them coming through. What's going on here? Show frame relay map. Okay, good. Well, it looks like it's learning about them from the service provider, and that's fine because LMI has to send the Delcies, but it's only doing the mapping for one of them because I turned off the inverse ARP. So it must have learned about these, but it's not actually using them as of right now. Okay, so we should be able to ping 172.16.1.1. Groovy. Now, back to what I was saying. Big problem already. We're sitting at Cactus. We can get to Goodyear. But here's the big question. Can Cactus get to Dogtown through Goodyear? You see that there's no direct permanent virtual circuits between Cactus and Dogtown because this is a hub and spoke topology. We save some money by only purchasing the PVCs we need. But can Cactus get to Dogtown through Goodyear right now? Let's try it. I'm on Cactus and I'll ping Dogtown. Ping 172.16.1.2. No, we are not. Why not? Well, the reason why is because as of right now, we only have one mapping. We only have one mapping to reach Goodyear using Delcy 401. So we wouldn't be able to reach Dogtown or Dixieland from our Cactus router. So what we have to do, and what you'll need to get in the habit of doing when you do static mappings, is create a mapping so that Cactus knows to go through Goodyear to get to those routers. Think about the syntax while I'm getting into this configuration mode. Think about what you would be typing for that frame map. Type in interface serial 0/0, and it will be frame map, and we'll be typing in IP. So to reach from Cactus, to reach the IP address of Dogtown, 172.16.1.2, what Delcy do we use? Now remember, we never go to a destination Delcy. We would never go to Delcy 301. That's only for Dogtown's use. Well, the only option is to use our own Delcy, 401. We've got one departing flight number. Let's use it because that's our only way out. So I'm going to say to get to to Dogtown, 172.16.1.2, use Delcy 401, and I'll always toss on that broadcast keyword, and we should be able to get there. So we're saying go out 401, that'll send us into Goodyear, and Goodyear should be able to handle it from there. Let's go ahead and type in the other one as well while we're here, because, by golly, we need to get to Dixieland. Oh, you know what? No, we won't. No. Here's why. If this was a pure multi-point configuration, I would have to create a map to get from Cactus to Dixieland. But look at this. I forgot for a moment that we're using two different sub-interfaces. This is point-to-multipoint to these two routers, to Cactus and Dogtown. This top one is point-to-point. It's a totally separate interface. So EIGRP should handle advertising this network out this, because it sees it as a totally separate network. It's going to say one interface is over here, one is over here. So I'm going to advertise this to these guys. EIGRP will take care of that. We don't have to worry about it. So Cactus should be good. So we should be able to ping, right? 172.16.1.2. Still not working. Well, remember, a ping is a two-way thing. Every time we go one direction, we have to come back. And if you think about it, Dogtown does not know how to get back to Cactus because it only has that base mapping right now, that one mapping to Goodyear. So let's go to Dogtown. Not too sure what's there, but let's just verify what our frame relay map is all about. We've only got that one to Goodyear. Let's get back to Cactus. Interface 00/0. Frame map IP 172.16.1. Cactus was .3, 1.3, and to get there we're using our own departing flight number of 301 broadcast. Lovely. We should now at this point be able to ping Cactus. Ping 172.16.1.3. Voila. And look at this. Interesting too. Yeah, I don't know if you noticed before, but when we pinged Goodyear, let's do that again. When we pinged Goodyear, it was pretty quick. Look at that. 56, 57 milliseconds. Once we're pinging now down to the Cactus router, we've doubled our time. That's because we're doing something called tandem switching. Dogtown has to go through Goodyear and then back out to Cactus. Yes, this kind of topology is cheaper to configure, but it does cost you in the terms of reachability and speed because everybody has to go through Goodyear. Good year. So it looks like everything is good so far. We should be able, let's do a show IP route. We should be able to now see, we're learning about Goodyear, and Goodyear's network is this one behind it, not shown in the picture. I kind of ran out of space there. 192.168.1 is behind Goodyear. 192.168.2 is behind Dixieland. It goes 2, 3, and 4. So I've learned about both of those. Those are our two behind the networks. I've learned about the 10 network. So look at that. Look at that. It's magic. I can now ping Dixieland. Yep, sure enough, I can ping Dixieland because EIGRP took care of that for us. But we're missing one. And this demonstrates a huge problem with multi-point interfaces. Look at this. We've got Goodyear's. We've got Dixieland's, but I'm sitting on Dogtown right now. Do we have Cactus's? Cactus has 192.168.1.4 as well, or .4.1 behind it. It's got this little network behind here. We aren't learning about that on Dogtown. Why not? Well, this is the evil of point-to-multipoint. I told you I loathe point-to-multipoint interfaces, and it's because of split horizon, demonstrated right before our eyes. Cactus is advertising into Goodyear about its 192.168.4 network. Let's verify that. Let's go over to Goodyear. Show IP route. And Goodyear, sure enough, is learned about 192.168.4.0 via EIGRP. 3.0, 2.0, 1.0. It's got them all. It knows about all of those local area network interfaces behind the routers. But it will not advertise it back out because it's going out the same sub-interface. That's split horizon in action. In this case, we would have to override split horizon on Goodyear. We'd essentially have to turn it off, and it's safe to do. We would go into interface serial 0/0.2. That's our sub interface. And I'm going to type in no IP EIGRP, or it might be, all right, there we go. No IP split horizon EIGRP, and hit enter. Oh, autonomous system number. Yep. No IP split horizon EIGRP autonomous system number. You notice instantly split horizon has changed. It's destroyed and rebuilt its peers because now I've completely disabled split horizon, and now Dogtown should know about that cactus network. There's only one way to find out. Show IP route, and oh, it's still rebuilding its EIGRP neighbor relationship right now, so it's still taking a moment to replicate those over, but give it a second, and we should start learning about those networks. Let me go ahead and pause the recording and give it a second to learn about those, and we should be good to go. Alrighty then, wouldn't you know it, as soon as I pause the recording, this little message shoots through saying neighbor has been rebuilt. So let me do the show IP route again. And sure enough, life is peachy. We have now learned about 192.168.4. We now have a complete network, but it wasn't through no trial of our own. There's a lot of weird things that happens with these point to multi-point interfaces. There's a lot of weird situations, and you really have to get used to working with them because they are the fork that will be thrown in your entire plan when you start using frame relay. Just to give you a good feel for a style of scenario you will encounter on the CCIE lab exam, this is what it would look like. This is a true hybrid configuration, some point-to-point, some multi-point, and some of them are restricted to using the physical interfaces only. You may encounter a scenario, I'll say hypothetically speaking, you may encounter a scenario to where you are not allowed to create sub-interfaces on your routers. It will restrict you from doing that. Only one hub router will be allowed to create those. So this is the style of frame relay topology to expect to encounter. So where have we been in this nugget? Well, I hope that I've had the opportunity to relay what took me years to learn with frame relay in just a few minutes with those key points and key terms that you'll need when you're learning to work with the service router and understand how the frame relay network communicates. And then we took the turn and jumped headfirst into the full configuration of frame relay. First off on a point-to-point connection, which is typical of the real world, and then we turned it to a really advanced configuration that you might see when you're starting to study for your CCIE lab with multi-point, point-to-point, hybrid configuration. Some of the other routers don't have any sub-interfaces at all. That type of topology is very typical to expect. In one of the upcoming nuggets, we're going to put the icing on the cake with frame relay traffic shaping. So I hope you'll join me for that because we'll learn to gear the frame relay connection to the speed that it should send at to communicate at that committed information rate. So I hope this has been informative for you, and I'd like to thank you for viewing.